Torque and angular momentum. When a force acts upon a body, then a straight line drawn from the origin of the force is called the line of action of the force. Torque. It is an axis of rotation which is equal to the product of the force of the perpendicular distance of the line of action of the force from the axis of rotation. It is denoted by tau. Tau vector is equal to product of F vector and R vector. This is also known as momentum of a couple. Angular momentum. If a body is rotating about an axis, then the sum of the moments of the linear moments of all the particles about the given axis is called angular momentum of the body about that axis. Let's take an example. Consider a body consisting of n mass particles of mass m1, m2 up to mn. Let the particles be rotating about an axis with a constant velocity omega and let r1, r2 up to rn be the distances of the mass particles to the axis. Moment of this force about the axis of rotation is equal to F into r. By putting values of force, we get m into r into alpha into r, which is equal to m into r square into alpha. Torque acting on the body is given by tau is equal to m1 into r1 square into alpha 1 plus m2 into r2 square into alpha 2 plus up to mn into rn square into alpha n. This equation can be written as tau is equal to summation from I is equal to 1 to n of product mi into ri square into whole alpha. This gives tau is equal to I alpha. If alpha is equal to 1 radian upon second square, then I is equal to tau. The moment of inertia of a body about its axis of rotation is numerically equal to the torque acting on it about the same axis when the body is rotating with a unit angular acceleration about that axis.
For more such videos on all subjects, practice questions and a lot more, download iPrep and learn unlimited.